You're going bright orange, you're either Texas or UT. All right, guys. We're going to look at addition and subtraction today. Looking at addition, subtraction. Now, addition, subtraction of these rational expressions is actually not too bad if the denominators are already the same. Because if they're already the same, we just add or subtract the numerators. So in this first one here, well, both of the denominators are already x minus 5. So we can add the numerators. So our 6 plus x plus 2. Well, the 2 and 6 would add together to be 8 over x plus 5. And this one here is nice because, well, the denominators are already the same, so we could add the numerators. But before we can officially be done, we need to make sure there's no greatest common factor in the numerator, denominator, or anything we can factor. Well, x and 8, there's no greatest common factor. X and 5, we can't do anything with. And again, because of the plus sign, these are stuck together. Yes, thank you. It is x minus 5. Thank you. Otherwise, I'd have to go back and do another annotation saying that it was another copy error. But yeah, so it should have been x minus 5. Yeah. And luckily, even with it being x minus 5, there's still nothing in common on top and bottom that we can simplify out. Questions on this here? Let's look at the next one. Now, again, luckily for us, they did factor the denominators to x plus 5 and x minus 2, but they are both the exact same thing. So that means we can add the numerators. And if we add the numerators, well, we're just adding, so we can go on and combine like terms. So in the first one, we have an x squared. And it'll just stay x squared because there's no other x squared in either numerator. The 3x plus 4x gives us plus 10, because negative 2 plus 12 is 10. Most likely, and it works out to be the case, that the numerator is actually factorable. About wrote plus. So we can factor the numerator. Now, since the 10 is positive, the signs are the same and match the sign of the middle term, which is going to give us plus and plus. X and x, yes, and 5 and 2. And if we did check it, we would see that this would give us 7x for the middle term. Well, do we have anything in common? And x plus 5, leaving us with n over x minus 2. And because the sign in the middle is different, we can't simplify this. And when we did this the first time, in some of the examples in the first time we covered this through, we did see that we could factor a negative out of one of them to get them to try to match up. But that only works if both signs are opposite. Because if we look at this here, the x's on top and bottom are both positive. So they match up, but the 2's, one's positive, one's negative. So there's no way for us to pull a negative out and get them to be the same. The only way that would work is if the numerator was actually negative x minus, or negative x plus 2, because then both would be opposite. So this here is as far as we can take this. Questions on this here? Let's look at the next one here. So this time we are subtracting instead of adding. Well, the denominators are already the same, yes? We would still want to factor them eventually, because just to make sure there's nothing in common on top and bottom. But we are going to be able to subtract them. We'll factor them in a minute. Let's see what the numerator does first. So when we're subtracting, the first numerator is going to stay the same. The x squared minus 2x plus 3 is not going to change. But we know that everything in the second one, the one that's being subtracted, the signs are all going to flip, because we are subtracting x squared. And we're also subtracting a negative 4x, which would make it plus 4x. And subtracting negative 5 will make it plus 5. And now, if we combine our like terms, well, x squared minus x squared is 0. It cancels out. Negative 2x plus 4x is 2x. 3 plus 5 is plus 8. Okay. Now again, we can't say we're finished at this point, just in case there are any like terms on top and bottom. Now the numerator, I know I can factor out a 2, yes? Which would leave us with what? X plus, wait a minute, is 4 a factor of 12? Okay, there's a good chance that there's going to be something in common on top and bottom. So we can factor the 2 out of the numerator, which will leave us with x plus 4 over. We need to factor x squared plus 7x plus 12, and we're hoping one of these turns out to be x plus 4. Yes, because the signs would be the same in both plus. We would get x and x, and it works out that it is 3 and 4, which means the x plus 4 and x plus 4 cancels, giving us 2 over x plus 3. And that's it. Any questions over any of this here? Are we ready for the next one? So unfortunately for this one here, the denominators are not the same. Now, using least common denominator, or really what we did yesterday, the least common multiple, we need to see what do I need to multiply both sides by so we get the denominators to be the exact same. Okay, nope.